Hey guys, welcome back to another lesson with Cody Harris Aviation. Today we're going to be going over the limitations section of the Robinson R44 Raven 2 in this particular case. So first thing I'm going to talk about is the color codes that you're going to be working with on the Airspeed Indicator, which is very roughly depicted over here. So the first thing is the red limit line, which is also known as the V&E, or velocity that you never want to exceed under any circumstances. So on the airspeed indicator, that's just marked by a single red line, and generally that limit is there either for structural load reasons. Perhaps part of the airframe might get damaged if you exceed it, but I believe primarily in the R44 that limit is actually there because you'll get retreating blade stall even at sea level if you exceed approximately 130 knots indicated. Next we have the red crosshatch, or the power off V&E. That is applicable only for auto rotation, and the reason that is there is because if you are doing auto rotation and sustain an indicated airspeed of above 110 knots, there will not be enough vertical airflow through the rotor system to maintain proper rotor RPM. Because as you start going faster than 110 knots, the airflow will start moving more horizontally across the rotor blades, and your rotor RPM will start dropping at that point. Next we have the yellow, or the cautionary range. So typically that will be a band on the airspeed indicator from 100 knots to 130 knots. From 110 knots to 130 knots. The purpose of that yellow band is basically to give the pilots a heads up that if they're in that range, they should be looking at the graph or at the chart in the pilot's operating handbook, because when you're in that range, you're at risk of retreating blade stall depending on the density altitude. Alright, next we have the green, or the normal operating range. So that would go from 0 airspeed all the way up to 110 knots, and that is just your general operating range. There's not really a lot of special implications of that. It's just your typical operating range. Alright, next we're going to cover airspeed limits. So these airspeed limits that I have on the board are only applicable up to 3,000 feet density altitude. So for at and below 2,200 pounds takeoff gross weight, you have a V&E of 130 knots indicated airspeed and 120 knots if your gross weight is over 2,200 pounds. For auto rotation, the limitation is, or the recommended airspeed is 100 knots. If you're operating at or above maximum continuous manifold pressure, the limit is 100 knots. I'm not quite sure where that limitation came from, the 100 knots for higher than maximum continuous manifold pressure. I'll have to look further into that. 100 knots with any of the doors removed. The purpose of that is, unfortunately, because a lot of passengers have put their arms outside the cockpit and have actually broken their arms doing it. Or another risk of that is if people try to stick their camera out, stick their arm out, it'll tend to break and or pull away anything that's stuck outside above 100 knots airspeed. Alright, next we have weight limits. So maximum gross weight for this helicopter is 2,500 pounds. Minimum gross weight is 1,600. So let me explain that a little bit better. So the maximum gross weight is there because anything over that would have a tendency to potentially overstress the components of the helicopter. The minimum gross weight is there because anything below 1,600 pounds will actually not let you consistently maintain proper rotor RPM in case of an engine failure. So that's one that people are often confused about. Next we have maximum per seat capacity. So in this helicopter that would be 300 pounds, and that includes up to 50 pounds per baggage compartment, as you can see on the next line. So the reason for the 300-pound limit is if you load someone up that's heavier than 300 pounds, it will likely throw the weight and balance of the aircraft off. another reason is if you have someone over that weight is that the crushable baggage compartment, that's sort of a safety device. If you overload that too much, it'll crush too quickly and not really do its job too well. Next is the minimum solo pilot weight, which is 150 pounds. So the reason for the minimum solo pilot weight, as far as I know, is just that if you have pilot weight any less than that, the helicopter really just can't consistently be loaded within weight and balance standards. So if you have someone of, let's say, 100 pounds, you're probably going to have to start adding a lot of ballast to the front right seat for your solo flights. All right, I think that's about it, guys. See you next Thursday. Bye.